Hello students, so we are going to discuss the next session paper. So let us start. First question is, this is for January 22nd evening shift, right? So if epsilon, capital E and T represent the free space permittivity, electric field and time respectively, then the unit of this, so this type of common questions are coming in dimensional analysis or dimensional units dimension chapter, right? So let us see that. And what is the key to crack such questions? Sometimes it may become very difficult if you try to use actual dimensional formula. So instead of that, what you can think about is you can try to find a formula for that, which you already know. You know a lot of formulas in that chapter. You try to make a combination of that which can give you quick result. Let us see that. Okay, so here what are the things given, and we have to calculate epsilon E by T. So epsilon E by T, dimensions of that we have to calculate. So let us think about it. What can we do? So let us keep epsilon as it is. Epsilon, let us keep as it is. Electric field, what can we write? Electric field, electric field we can write as 1 by 4 pi epsilon, right? For some medium, if you're taking 1 by 4 pi epsilon uh, q1 q2, right? Epsilon here, that means what? This is some medium you are writing electric field, and electric field is k cube by r square basically. So k cube by r square divided by t divided by time. Correct? Is what you have got. Right? Then what you will do? And note that this is free space, means generally we represent as epsilon naught. If you want, you can represent this as epsilon naught, epsilon naught. They will anyway get cancelled. So you are left with q by r square into t. And q by t is nothing but current, which is a fundamental. So let us write this as current divided by r square. Now let us write dimension. So dimensionally current is written as A, right? R square will be L square in the denominator, so L square will come in the numerator, L power minus 2, right? That will be the dimensional formula. Let us check that. So unit, they are asking, unit means ampere per meter square. You can write ampere per meter square, correct? Let us move to the next. Next question. Using simple pendulum experiment, G is determined by measuring its time period. So G formula, this G is nothing but acceleration due to gravity, but in a simple pendulum, time period has relationship with G, right? Okay, so we have to find correct relation. So you know the formula G, time period is what? Time period is 2 pi root under L by G, right? 2 pi root under L by G. Suppose if I square this and let us take proportionality. So T square is proportional to L by G. T square is proportional to L by G, and in the graphs they are given 1 by T square. So let us take 1 by T square. So 1 by T square will be proportional to G by L, correct? Right? 1 by T square is proportional to G by L, reciprocal. So which can be the correct? 1 by T square and length. 1 by T square and length. So let us get the relation between 1 by T square and length. So 1 by T square is like y axis here, right? Proportional constant, right? Okay, let us keep G as it is, divided by L. L is like x-axis, so you can take x into y is proportional to G, right? In this graph, which of the following plots represent the correct relation between the pendulum length L and time period? Okay, so if you consider G as constant, then what? Then xy is constant means it is a rectangular hyperbola. You know that such type of graph. So 1 by t square x and y proportional means you can go for this equation, this graph. Correct. Here we are keeping g as a constant because the graph is mentioning about that only. G has to be taken as constant. G is not a variable. Of course, using this formula, G is determined. So the first statement which they are talking about is a general statement. Okay. And the second statement which they are asking you to calculate, it is from the graph. Okay. So we need to identify that equation has to be transformed in this x and y. Right. Let us move to the next. Question number 3. Consider two boxes containing ideal gas A and B, right? That their temperatures, pressure, and the number densities are same. The molecular size of A is half that of B, and mass of molecule A is 4 times that of B. If the collision frequency, they are talking about collision frequency here, collision frequency. Okay, gas B is this, then the collision. So you need to get a relationship of collision frequency. So what is collision frequency? So we have some ideas about let us say mean free path. Okay, so if you try to understand collision frequency, collision frequency f, collision frequency f, it is nothing but 1 by time between successive collision. 1 by time between successive collision. This is the time between collision, you can say, between successive collision, because molecules will be moving randomly and they will be colliding. So time, this is nothing but the average time. This is average time. So this time can be written as distance by speed, distance, and the average distance can be taken as lambda, and average speed can be taken as v average. So basically this collision frequency is going to be V average divided by lambda. Okay, this is what, and we should know the formula for V average and lambda. So what is the formula for V average and lambda? We have to substitute it here. V average formula, let us see. V average, average speed, root under 8 RT by pi m molecular mass, right? Okay, mass in terms of molecule mass, let us write in terms of molecule mass. You can also write in terms of 8 kT by pi small m. Small m is the mass of one molecule, capital M is for 1 mole. Okay, so we can use that. And what about lambda? Lambda formula, mean free path. Mean free path formula is what? Mean free path formula, 1 by 1 divided by root 2 pi n d square. What is n here? N is what is number of collisions, or number of molecules, not collision, number of molecules per unit volume. That is called number density, I think. Yes, that is what is number density. So this n here is number of molecules per unit volume. So n is already given, you don't have to worry about that. Number density we have to, because number densities they are giving same. Okay, right? So let us think about it. So lambda will depend on the size of that, right? Molecular size they have given, d is nothing but size. So let us try to write this, fit in this equation and get this f. What will be f? Proportionality, let us write proportionality. So v average here, k is constant, same temperature, so it is inversely proportional to mass, root of mass, and here it is proportional to d square. Lambda is in denominator, remember that lambda is in denominator, so this d square terms will go in the numerator. Let us write like this, d square. Okay, So d square by root m. Now we can apply this question. What are the conditions given? Let us check that. So they are saying that everything else its conditions are same. So number densities, everything is same. The molecular size of A is how much? Half. A is half of that. Okay, and the mass of molecule of A is 4 times that of B. That means molecular mass and diameters. Okay, how many times it is changing, that you need to figure out. So if you are going molecular size of A is half, so you are comparing A and B. So and they are asking us to calculate A, right? So molecular size of A is half of that of B. If I take A and B and compare and make a table, like if I take A and B, if I consider A and B, right? So molecular mass and size of A is half of that of B. Suppose B I take as D, then this will become D by 2. A is half of that. And what about mass? Mass of molecule of A is 4 times. So if you take this is M, this is 4M. This is given, this condition is given, and they have given that collision frequency. So how many times frequency change, that is what you need to figure out, right? So frequency is depending on, so B you have take initial condition, A you have to take as final condition, right? So you are decreasing diameter by half and mass by 4 times. So let's think about here what you are going to do. D you are making as half, so 1 by 4 factor will come here. 1 by 4 factor will come, divided by mass you are making 4 times, so 2 factor will come here. 2 factor will come here, so you will be getting 1 by 8 factors. So 1 by 8 times you have to take, 1 by 8 times. So for A, if you want to calculate, it is 1 by 8 times of that. So 1 by 8 times means what? 32. This you divide by 8, you will get the answer. So 4, right? It will get cancelled 4. So the correct answer will be option 2. So in this question, we have tried to twist this conditions, but you need to derive this relationship. Some of you may, if you need directly, you can come and directly solve, but this is the approach how to do it. Okay, let us move to the next question. A uniform bar of length 12 centimeter and mass 20 meter. Okay, so length is given 12 and mass is given 20 m, not meter, it is 20 m. M may be some other mass. Okay, lies on a smooth horizontal table. 2 point masses m and 2m are moving in opposite direction with same speed of v and in the same plane as the bar as shown in the figure. These masses strike the bar simultaneously and get stuck to it. After collision, the entire system is rotating with angular frequency omega, the ratio of v and omega. Let us see the figure. Do we have the figure? Yes. Yes, this is the figure, this is the diagram, right? So what is there here? I think we can see here, this is what it is. Right, so we have here mass, this mass is 2m, this mass is m, right? It is going to hit, right, 12 centimeter it is there. From the center it is 2 centimeter this side, 4 centimeter that side. Correct, this is 4 centimeter I think, right? So what we need to find out is, after collision, the entire system is rotating with angular frequency omega, the ratio of v and omega. What is v here? What is v here? 2 point masses m and 2m are moving in opposite direction with same speed. Okay, they are moving with this speed v and they are going to hit. This rod was at rest condition, right? Okay, these masses strike the bar simultaneously, get stuck. Stuck means it will stick here, means what? If it sticks here means there will be what? Perfectly in elastic collision. So first of all we should think about the total momentum of this system. What is, so there are two things in such questions, there can be linear momentum and there can be angular momentum. So you can do the conservations of both, because all the forces and torques are internal, right? So net force is 0 and net torque is 0. System is in equilibrium, right? Both translational and rotational equilibrium. So we need to calculate V and omega. So let us first calculate linear momentum. Linear momentum system, if I calculate, so they are going in opposite direction. So downward momentum is how much? What is the downward momentum? Mass 2m into V, and upward momentum m into V. So what happens is that there is a net momentum. You can see that there is a resultant momentum. What is the net momentum of the system, or momentum of center of mass? What it is? So subtract it. So downward direction 2mv, right? 2m into v and m into v will give downward as m into v. Correct? You should not add them because they are opposite, so you have to subtract them, right? So this is the net momentum. So that means after collision, the center of mass will continue moving downward, right? Center of mass will continue moving downward. At the same time, there will be angular momentum conservation. Let us think about angular momentum conservation. So what is the angular momentum before? Angular momentum, you about center of mass you have to apply. So this is the center of mass. About this center of mass you are applying, right? This is the center of mass. This is the center of mass. About this you apply. So this is mv into r. How much it is? So 2m into v into distance, which is 2, right? Right. This is going like this way. And what about this side? This side. So m into mv into 4. mv into 4. How much this is? So this is also 4 mv, 4 mv. So what about the angular momentum, resultant angular momentum? So this is both in same direction are there, that means both are anti-clockwise. So angular momentum of the system angular momentum should be how much? You should add them. So it will become 8, 4 mv, 4 mv, 8 mv, 8 mv. So first we have got this. Now the system after collision, it will be rotating also, and it will be moving also forward. So when it will be moving after collision it will be moving downward with this p center of mass, right? This will be moving with p center of mass. Okay, now they are saying that what is the let us apply these conditions. Can we apply these conditions? Angular momentum. Note that here they are saying that the entire system is rotating with angular frequency. In the question they did not mention that it is having linear momentum, but you need to note that it should be considered. They are talking only about the omega after. So omega after, if I apply omega, just based on omega angular momentum, if I apply, so can we apply for the entire system as I into omega? Yes, I think we can apply this I into omega. So let us apply this I into omega. So system after, this was before and after collision, this should be I into omega. Okay, so what is I? Moment of inertia, you have to figure out. So this total mass of this rod is how much? Total mass of this rod is how much? 20 m and length is 12. So 20 m is total mass. So what will be the moment of inertia of this system? First of all, this rod will be there. Rod is ml square by 12. M is 20 m. Length is square. Length is 12. So 12 is square. Ml square by 12, right? Plus, what about the I of these point masses? So this is mr square. So 2m into distance how much? 2 square, plus what about this m into 4 square? m into 4 square into omega. So let us calculate this, how much it comes. This 12 12 will get cancelled here. Keep the units as it is. Okay. So 12 into 20, 240, 240 m plus this is 8 m plus this is 16 m, right? Omega. How much this comes total? Total you check out how much it comes. What is the total value? So this comes as 8 plus 16, 24. 24 you add here. So 264 m omega. Now because angular momentum is conserved, we can equate that. So let us equate that. Both of them you equate. So you will get 8 mv is equal to 264 m omega. So we are getting this condition from here, right? So what they are asking, ratio they are asking. So if they have actually asked, it would have been lengthy calculation, but they have asked ratio of v and omega. So v by omega ratio is going to be 264 by 8. How much it will come? Calculate. 8 into 324, 8 into 320, right? This will be the answer. This is going to be the answer of this question, although this question can go lengthy, but for JEE main within solving that much time, they have not asked for lengthy calculations. Fine. Let us move to the next question. Three small identical bubbles of water having same charge on each collides to form a bigger bubble. Then the ratio of the potentials on one initial bubble and that on the resultant bigger bubble is. Let us see quickly what the question says. There are three small identical bubbles. Okay, three bubbles are there. One, two, three, and they are colliding to become a bigger bubble. Correct? Having same charge on each. So charge is same. Q, Q, Q. So if they collide, total charge will become 3Q. Right? Then the ratio of the potential on initial bubble and that on the, suppose initial bubble have potential v, and finally we have, let us say, v dash. So they are asking you to calculate the ratio of potential initial by final v dash. This is what they are asking to calculate. Okay, so let us quickly see that. So potential formula is what? Suppose initial radius of each of them is small r and final radius is capital R, right? So let us first see, we should always know here that the volume will be conserved. So you can conserve the volume. From volume conservation, this type of questions you have already known that the final radius r comes as initial radius into n power 1 by 3, where n is the number of bubbles. There are three bubbles. So r into 3 power 1 by 3, right? This is the final radius. This is based on volume conservation. That's all. So you know about this. Now potential formula V is proportional to K Q by R. Q by R. So this is Q by small r, and V dash will be proportional to total charge is 3Q divided by capital R. Now you take that ratio. So when you take this ratio, what do you get? Now when you take that ratio, what do you get? P by V dash. So Q factor will go away, right? Q will go away and R will come. So that means capital R will come, small r will come, and here 3 factor will come, right? So let us try to calculate R. You substitute now, small r, right? Capital R by 1, 3 per power 1 by 3. 3 per power 1 by 3 by 3. So how much it will come? It will come how much? 1 by 3 per power 2 by 3. Correct? 3 per power 2 by 3. So which is the correct answer? Option 4. Clear? Let us move next. Okay, let's go to this question. In parallax method for the determination of focal length, of a concave mirror, the object should always be placed between the focus F and the center of curvature C of the mirror only. At any point beyond focus, beyond the center of curvature of mirror only, between the pole P and the focus F of the concave mirror only. So what is this question? Let us think about it. So there is a concave mirror, and you consider this is the principal axis. So suppose this is focus, this is pole, this is center of curvature, this is beyond. So in parallax method, what is parallax method means? You have to consider rays which are making very small angles. It is paraxial rays, not the marginal rays, and all the formulas of mirror or lenses are valid for paraxial rays. That means you can apply all the formulas. Now they are saying that we have to make a image, and definitely you have to find the distance or measurement has to be done. So the image has to be real images. So we cannot keep object in between pole and focus. Object can be anywhere in this side, so we will be able to get a real image. Idea is to get real image. Okay, idea is to get real image, because if you get real image, then you can measure that distance of image, you can measure the object distance, and then you can use the formula 1 by f is equal to 1 by v plus 1 by u. Vu you will calculate from experiments, then you can find out the focal length. This is the method, paraxial method. The only condition is paraxial means the rays are making small angles, or the rays are paraxial rays, so that mirror formula will be valid. Okay, so definitely any point this side, beyond this side, any point you take, that means object can be kept anywhere. So what is the option? At any point beyond focus? Yes, beyond focus we can go for that, any point beyond focus. And when you see other points like beyond center of curvature C of the mirror only, so only should not be a condition, only should not be a condition. Okay, other is not possible. This is anyway not possible, so this is also not possible. Between focus and center of curvature only, again only is not a condition. Beyond this you can choose second option. Fine. The smallest wavelength of Lyman series is 91 nanometer. The difference between the largest wavelength of Passon and Balmer series. So Lyman, then Balmer, then Passon, all those series comes in hydrogen spectrum, right? Smallest wavelength. So what happened in Lyman? We should know about that. Lyman. What happens in Lyman? So n is equal to 1. Jumping will happen on n is equal to 1, right? Smallest wavelength. See, smallest wavelength means maximum energy or highest frequency. For that you have to consider from infinity it is coming, right? So this wavelength only they are asking. So we can calculate this wavelength. We can use Rydberg formula also, right? So Rydberg formula, if you use 1 by lambda is equal to Rydberg constant into 1 by 1 square, and that infinity will become this. So this is 1 by Rydberg constant, right? This is what it is for Lyman series they are talking about. Okay, so if you want, you can give the value also. You can substitute this value because they have given that as 91. Okay, the difference between the largest and smallest wavelength of Passon and Balmer series. Now, if you take Passon, Lyman, Balmer, you take first Balmer, and then you can take Passon, right? So this value, let us write this lambda 1, that is given as 91. Difference between largest wavelength they are talking. Largest wavelength means energy is minimum, and that means minimum transition you have to consider. So Lyman Balmer means n is equal to 2. It will jump, that means minimum means difference, energy difference means n is equal to 3 to 2 you take, and Lyman Balmer Passon means from 4 it can jump, so 4 to this. Okay, so then apply that. So 1 by, let us write this as lambda 2 and let us write this as lambda 3. So this formula is Rydberg constant, right? 1 by this is square minus 1. So this will become how much? 1 by 2 square minus 1 by 3 square. So how much it will become? How much it will become? Calculate this. So from here this will become as 4 and 9. 4 9 36, you can take 36, correct? 36, and this 9 minus 4 5, so 5 times Rydberg constant. Here what will happen? Rydberg constant 1 by 3 square minus 1 by 4 square, correct? So how much it will become? 3 square 9 and 4 square 16. 16 into 9 it will become, correct? 16 into 9, which is 144, we can take that, and 4 square minus 3 square, so 16 minus 9, this will be 7. 7 times Rydberg constant, correct? So we got this. Now they are asking the difference of the this lambda to lambda 3 difference. If you calculate lambda 2, what will be lambda 2? Let us write lambda 2. What is lambda 2? Lambda 2 is equal to 36 by 5. 36 by 5 Rydberg constant. 5 will go in denominator, right? So Rydberg constant goes in the denominator. So this 5 Rydberg constant is what? Reciprocal of Rydberg constant is lambda 1, correct? So this is 36 by 5 lambda 1. Similarly, what is that lambda 3? Calculate. Lambda 3 is how much? 16 into 9. 16 into 9, 144, let us write, divided by how much? 7 Rydberg constant. 7 Rydberg constant. Rydberg constant, again you substitute as reciprocal of that, so lambda will go there. So 144 lambda 1 divided by 7. Now you need to take the difference of this, so let us calculate the difference of this. This calculation you have to do now. Yes, what is the difference of these terms? Difference of this. Okay, so this is of course pure calculation. Pure calculation is, we cannot do anything about it. You need to subtract and do calculation. So what is lambda 2? Can we calculate the value of lambda 2? This is 36 by 5 into lambda 1. How much was that lambda 1 given? Lambda 1 was 91. 91. So can we subtract it? Yes, do that. This is 91. And what is lambda 3? 144 by 7 into 91. Correct? So I think we can take 91 common. And here this factor, which is greater factor here? 36 by 5. So 5, 7.2 it will come. So this is 7.2 into 91. And this one is how much? 7, 2, 14. 20 point something will be there, correct? 20 point something into 91 will come. So this factor is larger, so lambda 3 minus lambda 3 minus lambda 2 you calculate. Suppose if I take 147, then I can take approximation, right? And here the values are close by, so better not to take approximation. You have to calculate this. How much approximately it will come? 7 to 14, then 4, then 40 will come. So 7, 535 will come, again 557, 7. So 20.57. So subtract this 20.57 minus 7.2 into 9, 1. How much this will come? Subtract. So from here 37, 37, right, after decimal, and this will be how much? Sorry, yeah, this is correct only. So 20 minus 7 you have to take, that means 13 into 91. This calculation now you do. how much this will come. Check out this value. Check out this value. This will be 100 in denominator. Calculate. So 1337 will come when you multiply with 91. Then 9 into 7, 63. 6, 9 into 3, 18. 18 plus 6, 24. 2 will be there. 9, 9 into 3, 27. 28, 29 will be there. 2 will be there. 9, 10, 11. So check that. 7, 6, 7, 0, 2, 1. And decimal. So 1207 nearly. Check that. 1207. I think you can check this. 1207 or 17. Here 07. Maybe this is 17. Okay. Let us go for option number 3. Okay, so calculation is there. Let us move to the next question. In an open organ pipe, V3 and V6, I think these are frequencies, third and sixth harmonic frequencies respectively. If the difference of this is given, then length of pipe is. Direct formula is there. What is that? Open organ pipe. This is open organ pipe like this. Okay. Third and sixth harmonic is, so you know this start with odd harmonics, so the frequency is given as odd harmonics, odd into V by 4L, right? This is the formula. So first odd means 1, next will be second, and next is third harmonic, because here only odd harmonic exists. Open, no, this is closed, sorry, this one is closed, we have to take open. Open means this one, both sides. So here frequency will be n into V by 2L, correct? This is open, that was closed. Okay, open means both are open, right? So first here all harmonics exist. Third means this will be 3, so 3V by 2L. And sixth means 6V by 2L. So this difference they have given as how much? 2200. 2200. Okay. Over, and what is the speed they have given? 330. So speed you can take common, right? Speed you take common. So you take speed common. So 330 into 12 also you can take common. 2L is coming common, and 6 minus 3 will give 3. So 2200, right? So let us cancel now. Some cancellation work you can do. 0 will get cancelled. 11 into 20, 11 into 3, right? So what will be the length here? Length you calculate, and everything is in SI unit, so use SI unit calculation. So length will be how much? 3 into 3, 9, 9, and 20 into 2, 40, right? 9 by 40. This is in meter, but here we have to calculate in millimeter, so 1000 you have to multiply. 1000 you multiply. So what do you get from here? Check out. So this become, even 2 can be cancelled. So 2 into 50, 2 into 2. So 9 into 5, 45. 450 by 2. 450 by 2 is 225, correct? So you can go with 225. Let us move to the next. Okay, so let us go to the next question. When a part of a straight capillary tube is placed vertically in a liquid, the liquid rises up to certain height h. If the inner radius of the capillary tube, density of the liquid, and surface tension of liquid decreases by 1%, then the height of the liquid in the tube will change by. So this question is related with the capillary rise height. H formula we know, 2t cos theta by rho gr. We can use this, yes. Now when we want to use this equation, here what are the things they are changing? density, density changing, then surface tension, okay, inner radius. So r, density and surface tension, they are changing. How much? Decreasing by 1%. So when they are decreasing by 1%, can we apply error analysis? Delta h by h into 100 is equal to, here power of t is 1, so plus 1 into delta t by t into 100. Here power, this is in denominator, so it is minus 1, right? So minus 1 into delta rho by rho into 100, and again r is also in denominator, so power is minus 1, so minus 1 into delta r by r into 100. So what is given in the question is the tension is decreasing, so delta t by t into 100, this is of course minus 1. Decrease means minus 1. Similarly, delta rho by rho into 100 is minus 1. Similarly, delta r by r into 100 is minus 1. Correct? Right? Everything is decreasing by 1%. Now we will substitute here. So delta t by t is, this become minus 1 here, right? Here minus minus will become plus 1. Here also minus minus become plus. So we get 1%. Positive 1% we are getting. Okay, so the correct answer for this will be option 4. But remember, in error analysis generally we do not write the signs of plus minus, we take maximum error, right? But in this question, they have given as decrease, so according to that you need to check this sign, plus or minus. According to increase it is plus, and according to decrease it is minus, right? Fine. Okay, let us take this question. The correct truth table, the correct truth table for given input data, we have to calculate the truth table, find out the truth table. So first of all, what we can do is we should try to find a expression for this. What is the expression of this? Let us try to calculate the expression for this. So you can see here, this is AB, so it is A dot B, and here it is A dot B bar. Then here C plus B, C plus D it is. Then this is again dot, so this is coming as A dot B. Then this is getting dot with C plus D, right? And over that bar we have to take. So what is the output? Output y should be A dot B bar C plus D. We have to put a bar over this, right? Now let us try to simplify this. So this can become A dot B bar bar, and this dot will become plus, right? And this will become bar over this C plus D bar. Okay, correct? This is going to happen. Now here bar will get finished, it will get removed, and it will become A dot B. Then it will become A dot B because bar gets removed. So this plus C plus D bar you are getting, C plus D bar. What will be C plus D bar? Okay, let it keep like that. I think now you can try to solve it and check each option. Start with option 1. So A dot B, here 1 dot 1. 1 dot 1 will give what? 1 only. So this 1 dot 1 will give 1, and C plus D, or that will also give 1, and 1 plus 1 is 1. So this is coming as correct, right? Next 0 0 dot means it will give 0, right? It is going to give us 0. And then C plus D is giving us 1 only. So that is 1, and over that we have to take bar. Let me just check this one. First one, 1 plus 1 it was 1 1 1 1 will give 1 plus plus means that can be anything. Plus means our operation, that is 1 on anyway. So here 0 0 is 0, this is going to be 0. What is C plus D? This is 1 plus 1, and its bar means give 0. 0 will come, correct? Then same way 1 plus 0, so dot means both should be, so it is going to be 0 only. This is going to be 0, a dot b will be 0, and here this will be 1 over 1 bar means it will become 0, so this will become 0 0. 0 plus 0 should give 0. So I think this is not correct because it should give us 0. Hmm? Then what about this operation? 1 1 will give 1, C plus D 1, opposite 0. 0 plus 1 will give 1. So this option should also be 1. So just same thing is happening here. All the options are arranged in the same way. So now you check, the correct answer should be 1001. Let us check that. 1001. 1001. This is the correct answer. Yes, so we are getting this option number 2 as the correct option. You can check other option. 1001 is coming in others. 1001 is not there. So second option is the correct option. Let us move to the next. Question number 12. An electric power line having total resistance of 2 ohm delivers 1 kilowatt of power to 250 percentage efficiency of transmission line. Electric power line having total resistance of, so there is a line, transmission line. Okay, so this is like the secondary side, and in a transformer this is like the primary side, secondary side. So some resistance is there. Electric power line having total resistance, so this line has a resistance of 2 ohm. 2 ohm delivers 1 kilowatt power, 1 kilowatt power of 2 1 kilowatt power of 250 volt. Suppose if there is some device which is connected to this, right, then the power which is delivered, his power is given as 1 kilowatt. Okay, and output voltage is 250 volt. Percentage efficiency percentage, so that means input output we have to see. This power is like output power only, this is like output power, correct? We need to calculate input power. How do you calculate input power? How do you calculate input power? Are they asking percentage efficiency of transmission line? Are they asking output by input here, secondary to primary? What they are asking? That is also important thing to know, what they are asking. So here power and voltage they have given, so we can calculate current. What is the current? So I think transmission line, these two lines, right, this total resistance they have given for this. So I think how much energy got lost during transmission, because this like a transmission wire, so there will be some loss of energy happens through this when power is transmitted. Okay, so we can calculate the loss of power through this. So for that, I square R we need, current we need to calculate. So P is equal to V into I. Can we use that? So current we can calculate from here. I is equal to P by V. If I take this 1000 by 250, that means it is 4 ampere current is flowing. 4 ampere current is flowing. So because of that 4 ampere, how much loss happens? Loss is I square R. So 4 square into this resistance 2, So 4 square 16 into 2 32. 32 watt, 32 watt is loss. So that means input should be more, which should include the output plus loss. So input will be what? Input you can consider as output plus loss, plus loss. So this is 1000 plus 32, so 1032 watt. Now let us calculate efficiency. Efficiency is output by input, so percentage efficiency or just efficiency, percentage efficiency. So output by input, output by input, output is how much? 1000 by 1032 into 100. This you need to calculate. Near to how much? Yes, this you need to calculate. Maybe some binomial approximation you can try that. Suppose if I take 100, 1000 can be cancelled. So in denominator we can put 1.032. So 1 plus 0.032 we can put, and we can take in the numerator and try to calculate, right? So how much it can become? Check out this. So percentage efficiency can become equal to 100, and this will become 1 minus 0.032. Approximately how much it will become? Let us calculate this. So 100 minus this become 3.2. Nearly how much it will become? 96.8 nearly. Yes, 96.8. So you can go with the first option, 96.8. Fine. Let us move to the next question. Question number 13. The wavelength of light while it is passing through water is this. The refractive index of water is this. The wavelength of same light when it is passing through transparent medium having refractive index. So we know that wavelength is equal to wavelength in vacuum by refractive index. So this formula we should know. Okay. So they have given in water wavelength, they have given 540. This lambda naught divided by mu is 4 by 3. Next they are asking in some other medium, that lambda we have to calculate, right? Lambda naught divided by refractive index 3 by 2. So just take the ratio. This is first, second by first you take. So lambda by 540, lambda by 540, and this become 4 by 3 by 3 by 2. So it is going to be 8 by 9. So lambda is 8 by 9 into 540. So 9 into 7, 8 into 7, 560. Correct. So are we correct? Nearly. I think this I have taken as nearly. It will be less than that, not 560, it is 530. So 9 into 6, right? So 8 into 6, 48, 480. 480 will be the correct answer. Correct? Right. So this is the answer. Let us move next question. Let us move to the next question. Figure shows the circuit that contains three resistances, 9 ohm each, and two inductors, right? Like this. The reading of ammeter at the moment switch key is turned on. Where is the switch? This switch is turned on. Okay. Is the reading of ammeter the moment switch is when you are turning the switch, that time they are asking reading of the ammeter. That means what will be the current flowing through this. So we should know inductor circuit, what happens when, and initially when you press it, what happens there, how does it behaves. This fact we should know. A capacitor initially behaves as a conductor and finally it behaves like an insulator, right? And here this behaves reverse. Initially it behaves like an insulator, so when we press it will behave like an insulator. So that means you can consider here that initially it is behaving like an insulator. That means it will not allow any current to pass. Okay, So we have to only consider this branch. This branch only you consider. So 9 volt and this 9 ohm. So current which will be considered as 9 by 9, we should take as 1 ampere, right? So you can go directly with 1 ampere, because when it becomes steady state, then current is maximum, then only current will flow maximum in that branches, right? Let us move to the next question. Given below two statement 1, satellite is moving around Earth in orbit very close to the Earth's surface. Time period of revolution satellite depend on density of Earth. Time period of revolution. Time period is equal to what? What is time period formula? Time period formula. Does time period depend on the mass of Earth? Definitely it depends, right? Time period formula can be written as 2 pi r by v if you want. Then this radius is our velocity, is orbital velocity, root under gm by r. So you know that time period is proportional to, here r power, even r you can take inside, so it will become square root r cube by mass. So mass, okay, now density, mass you try to write in terms of density. So mass is equal to density into volume. Volume will come in terms of r cube. So it is only inversely proportional to 1 by root density, correct? So definitely this first statement, what they are saying, that time period of satellite depends on the density. So according to this, time period is proportional to mass is density into volume. So it will come root under density. So this statement is correct, right? Statement to the time period of revolution satellite is 2 pi root under r by g for satellite very close. Then this is wrong. This is anyway going to be wrong only. So this we can reject. Okay. R is radius. Okay, now you see G, in terms of G they are writing. Once you also check in G, this is in G form. G is Gm by R square. Gm by R square. Yes, this is also correct. Gm R square R cube. This is also correct, right? Where R is radius. Okay, so that means both statements are correct. Both statements are true. You can go for this. Okay, fine. Let us move to the next question. Which of the following are true for a single slit diffraction? Single slit experiment. Width of central maxima increases with increase in wavelength, keeping slit width constant. Width of central maxima. That means beta, fringe width, beta is lambda d by d. Correct? The width of central maxima increases with increase in wavelength. If you increase the wavelength, this will also increase. Correct? That is a fact, right? That is correct. Width of central maxima increases with decrease in wavelength, keeping slit width constant. This is not correct. Okay. Width of central maxima increases with decrease in slit width. Decrease in slit width means d, if you decrease, this will increase. That is also correct. This is also correct. Okay. Width of central maxima increases with increase in slit width as constant wavelength. So then this is wrong, right? This is wrong. What about the brightness of central maxima increases for decrease in wavelength at constant slit width? Decrease in wavelength, and this is single slit experiment. Brightness of central maxima increases for decrease in wavelength. So they are saying about the intensity. Intensity decreases when lambda is decreases. Is this statement correct? Intensity, and this is related with single slit. Single slit. Let us first check about what we know, which is correct. So we know first statement A and C are correct, right? A and C are correct. We know that. We need to choose which option. Which of the following are true for single slit? Width of central maxima increases with increase in wavelength, keeping slit width constant. Single slit no, single slit, it is not double slit, sorry. Single slit means what will be that width? Y. Correct. The radius of the first spot, first dark spot. What is that radius? First minima, b sine theta. B sine theta is n lambda. That is what is lambda. So theta is y by capital D. Theta is y by capital D is lambda. So y is d lambda by d. So what about this width of central maxima increases with increase wavelength, keeping slit width constant. So if you increase that, then this is correct only. This one is correct only. A must be correct. Okay. What about this width of central maxima increases? Why? Decrease in wavelength. Wavelength is decreased, so this is wrong. Correct. That is wrong. Width of central maxima increases with decrease in width at constant wavelength. Decrease. If you decrease that wavelength, so it will also decrease. Right? Width of central maxima increase will decrease. So this is wrong. You are decreasing, right? So this is also wrong. So A is definitely correct. What about this? Central maximum increases with increase in wavelength. So wavelength increases, central maximum increases with increase in slit width. Slit width means B, I think. If you are increasing, then that will also increase. This is wrong because it is inversely proportional. What about brightness? So A is definitely correct. E we need to check. A is definitely correct. D is wrong. D is wrong. ADE, how it is possible? D is wrong, right? Width of central maxima increases with increase in slit width. Increase in slit width at constant width. Slit width, if you increase, this Y will decrease, right? So I think there is some mistake with that. D cannot be correct. E we can see based on intensities approach, but D cannot be correct. Here also D cannot be correct. Here also D cannot be correct. And we have only there A. So again some problem with the options. Leave it. Given below are two statements. Statement 1, object moves from position R1 to position R2 under conservative force field F1. Work done by forces. Work done by conservative force is minus statement 1. So is this statement correct? Work done. So what is work done by conservative force? What is F? Is F conservative field force? Conservative force. Work done by forces. Work done by force will be integration of F dot dr. Why minus? Minus we cannot say. Okay. Work done we cannot say minus. But one thing we can say that work done is conservative force is minus change of potential energy, because potential energy will be defined by that. Okay, so that work done is minus change of potential. So first statement itself is wrong. Work done by force is minus integration of F dot dr. Okay, this statement is wrong. This statement itself is wrong. Okay, so first statement is wrong. Second statement, any object moving from one location to another location can follow infinite number of paths. Therefore, the amount of work done by the object changes with the path it follows for a conservative. Any object moving from one location to another location can follow infinite path. Therefore, the amount of work done by the object changes with the path followed. No, so path is It is independent of path, right? So this statement is also wrong. This is wrong. So both options are wrong. Both are wrong. Let us check. Both are false. Okay. Let us move to the next question number 18. Five positive charges each having charges placed at the vertices of pentagons on the electric potential and electric field at the center of the pentagon due to these five positive charges. How do you calculate, right, at the center due to positive charges? Electric field we need to calculate. Potential also we have to calculate. So potential will simply add as vector quantities, right? Potential, potential will add as vector quantity k cube by r. So k cube by r, simply try to add k, q means 5 times 5 cube by r, that will come symmetricity. And see, there is a symmetricity, right? Symmetricity is there, so electric field must be 0, because in a symmetric polygon, if you keep the same charges, then electric field must cancel out. You can take that. Electric field must cancel out, so electric field will be 0. So we can go with option number 1. No, nothing to be done in this. Okay, let us move next. A laser beam has intensity this. The amplitude of magnetic field associated with beam is. Laser beam intensity is given, and from that intensity we have to calculate magnetic field. How to calculate this? So intensity is given in terms of watt per meter square. But we have the formula for energy density. What is that? Energy density. So if you know that 1 by 2 mu naught into b square, can we use this formula? Average energy density. How is energy density? And this is related intensity and energy density. Yes. Energy density means what? Energy per unit volume. Right. So I think if you multiply with this speed of light, you will get this I. So using this we can solve, I think. Yes. So b square, b will be root under 2 mu naught I by c. Let us try this. So b will come as root under 2 mu naught. Mu naught is 4 pi into 10 to the power minus 7. I is, I they have given 4 into 10 to the power 14 divided by c, speed of light 3 into 10 to the power 8. This you need to check out now. So this will become how much? 4 4 16. 16 into 2 32. Pi by 3 is coming. 10 to the power how much? Minus 10. So tan factor will come in denominator, right? So even you can write this as now check out the answers which can be possible. It cannot go that much large value, 5.5 or 18.3. Out of this only you have to choose, right? So this you need to calculate. I think this is 16 into 2. 2 you can cancel, so 4 will come out, root under pi by 15, correct? Root under pi by 15. Now if I take also approximately this as 16, then 4 will get cancelled out and nearly pi. So root under pi means root 3, 1.7 something it can come. So it can come option 4. It can come approximately 2, it won't come. Okay, let us move to the next. Light is incident on a metallic plate having work function this. If the produced photoelectrons have zero kinetic energy, then the angular frequency of the incident light is. So work function is given. Photoelectrons are zero kinetic energy means the energy which you have given, because kinetic energy maximum formula is E minus work function. So if this is 0, so that means energy is equal to work function, right? What we have to calculate? Angular frequency omega, or frequency of incident light. Frequency you calculate. So h into frequency is phi. So frequency is going to be phi by h. Phi is how much? Work function they have given 110 into 10 to the power minus 20. This is nearly 6.6 into 10 to the power minus 34. If I take this value nearly, so how much it will come? Then extra 10 will come here. So this will come 1 by 6, 11 into 6, and this 100. So 10 to the power how much? 36 minus 20. 16. Okay, and if I take this as 10 by 6 into 10 to the power 15. So it is 5 by 3, 1.66, 10 to the power 15. So option number 4. Angular frequency it is not, it is frequency. So this word may be misleading word. Okay, let us move to the next. Then a conducting circular loop is rotated about its diameter at a constant angular speed of 100 radian per second in a magnetic field of this perpendicular to the axis of rotation when the loop is rotated by 30 degrees from horizontal position. The induced EMF, this radius of the loop is. So this is rotation of a loop, alternating current, right? Rotated about diameter, constant angular velocity, magnetic field. So what is the formula for EMF? NBA omega sine omega t. This is nothing but the angle theta, right? So how much angle it is making? When the loop is rotated by 30 degree from the horizontal position, the induced EMF is, EMF value is given 15.4, right, milli 10 to the power minus 3. Okay, so n, how many loop are there? One only, one. Magnetic field is how much? Magnetic field is 0.5. Area of the loop, area can be written as pi r square. And what about omega? 100. What about sine theta? So here note that if this, how is magnetic field? Which direction it is? Magnetic field is perpendicular to the axis of rotation. So axis of rotation, let us say like horizontal. So you can take magnetic field like this way. So here the plane of the loop, and this is the normal vector. So this angle we are talking about, right? So the question is, when the loop is rotated by 30 degree from the horizontal position, so that means initially it was like this. So initially it was making like this. Okay, so now it has rotated like this. So now it may go 30 degree this way, correct? 30 degree it will be going like this. 30 degree will be that. So how much angle the area vector will make? Area vector you can consider like this way. So it is going to make this direction. So 90 plus 30 it will be. Remember that 90 plus 30, sine 90 plus 30 you have to use. Sine 90 plus 30 will be cos 30. Cos 30 will be root 3 by 2. This is what you have to use properly. Then I think you can solve this, right? Correct. So this is about the solving this equation. So we can do it obviously. So thank you all for your attention. Then you can work out remaining. So let's continue the next question. What's the next question? A conducting circular loop is rotated about its diameter at a constant angular speed omega is given in a magnetic field 0.5, okay, Tesla perpendicular to the axis of rotation. What when the loop is rotated by 30 degree from the horizontal position, the induced EMF is this. The radius of the loop is, first you need to understand what direction of magnetic field and the area vector, right? So conducting circular loop rotated about diameter, okay, in a magnetic field this perpendicular to the axis of rotation. Suppose magnetic field is this way, let's say this is the axis of rotation perpendicular, and magnetic field is perpendicular, both are perpendicular to each other. So let us take a diagram like this is the loop, and area vector will be up right now, right? Area vector, and magnetic field will be perpendicular, so you can take magnetic field as horizontal, right? So right now the angle between them is 90 degree. You can see that right now the angle is 90 degree. Now it is rotated, okay, when the loop is rotated by 30 degrees. So if loop is rotated by 30 degree, this area vector will also rotate, right? 30 degree, this angle will become 30 degrees. So angle with magnetic field will become how much? Angle with magnetic field will become that theta, which will be 90 plus 30 degree, right? That means 120 degree basically, okay. And they have given induced EMF. So you know already the formula for EMF induced. EMF induced is NBA omega sine theta. Theta is nothing but omega t, right? So this angle is given sine 1 on 120 degree. Number of turns, there is only one turn, single loop is there, so 1 you can take. Magnetic field is 0.5. They are asking the, what they are asking, radius of the loop. So radius means you can write area as pi r square. Let us write this is pi r square, and sine omega is also there. What is omega? Omega is 100, and sine of 120 degree root 3 by 2. And this EMF they have given how much? 15.4 millivolt. So 15.4 milli means you can divide by 1000, right? So you can try to solve it now. We need to calculate the radius, okay. So can we cancel out something? Try to check some calculation. What will be r square? Let us calculate r square. R square will be how much? This is 1 by 2, right? So this will come 4 here, 4 here will come. So what it will be? 15.4 by 1000 into, this is half, so 4 will come here. By 100 you can take 100 will come here, root 3 also will come here, pi will also come, pi. What should we take the value of pi? Should we take it as 22 by 7? Maybe that may be easy to solve it. Let us take that 22 by 7 and try to solve that. If I consider that as 22 by 7 and try to solve this r square, what will be r square? Here I can take it as 154 into 4 by 10 to the power 4, 5, 6. 10 to the power 6 will come, root 3, 1.732 also we can write, let it keep afterwards, but pi you can write as 22 by 7. Now this 22 seems to be cancelling, no? 22 will cancel with 154. How many times? 22 7 times, correct? 7 times it is getting cancelled. So what are we getting r square as? R square, 7 into 7, 7 square is coming. 4 means that is 2 square. 10 to the power 6 means 10 to the power 3 whole square. correct? Only root 3 factor is coming, which is not coming as perfect. Okay, so if I take as r square and try to solve this, what I will get as r? R I will try to get. Square means 7 into 2, 14. 14 by 1000, that will come, right? And 1 by 3 per power, half factor 1 by 4 it will become, correct? This will get this one. Now what can we do from here? If you want here, you may do some simplification, correct? But in millimeter, if you consider, so in millimeter it will become uh, 14 by 3 power 1 by 4 millimeter, correct? So I hope this may not come as exact, integer. What it will come, this calculation we need to do then. 3 per power 1 by 4, what can we write? What can we write? This calculation is not coming correct, because according to the formula that we have to use, it is not sine 30 degree. If it is sine 30 degree, then this root 3 factor will not come. If root 3 factor is not coming, then we will get 14, correct? So we need to consider the angle between the area vector and the magnetic field, correct? Which angle should we take? Should we take 60 degree? Because if you take 60 degree, even sine 60 degree will give root 3 by 2, right? Because they have given here that the angle between them is what? So it is rotated 90 degree. Initially it is given that it is horizontal, right? It's not that the plane is vertical. What they have given, when the loop is rotated by 30 degree from the horizontal position. So horizontal position means that loop, we are interpreting it like that the loop is initially horizontal. If the loop is initially horizontal, so initially it will be making 90 degree. Initially it will be making 90 degree with that. So I think there is a confusion in the question, that clarity is not there. But if you take angle here in this sine 30 degree, then you'll get 14 millimeter. But in actuality, according to the diagram that we should consider in the question, we should take as 120 degree, and then you can do, or even you take 60 degree, because either you take 120 degree or 60 degree, you will get same sine of 60 degree or sine 120 degree will come same, right? Okay, let us move to the next question. Two masses m and 2m are connected by a light string going over a pulley of disk mass and radius this. The pulley is mounted on a vertical plane and is free to rotate about its axis. Right? The 2m mass is released from rest, and its speed when it has descended through a height of 3.6 meter is. What is the question? Diagram I think is not given, but let us consider here. Two masses m and 2m are connected by light string. Okay, disk. So this, that means you need to consider rotational effect of this pulley. This pulley is like a disk, right? And it is fixed somewhere, the vertical plane. And this string, one mass is 2m, another mass is m, right? And the pulley mass is how much? 30m. Pulley mass they have given as 30m. And pulley is like a disk. Okay, so these things are given. They are saying that when it has descended, 2m is released. So this of course will be going downward from this height. It will be going upward. Okay, so it has gone to some height. How much height it is? 3.6 meters. 3.6 meter. Initial speed was 0. Finally, what will be that speed? That is what they are asking. Both the speed will be same, right? So what is that speed they are asking to calculate? So if you know what is the acceleration, then the game is over, because if you know what is the acceleration with which it is coming, right, that acceleration, if you know, then v is equal to root under 2ah. We can use that, right? Now the thing is that to calculate acceleration, this is a rotational system also. You should know direct formula for that. What is the acceleration formula here? m1 minus m2, 2m minus m into g divided by m1 plus m2 plus I by r square. This factor I by r square is the additional factor that we get in the what? Atwood machine, right? So I is what? I is for the disk. This is I of the disk, radius of the disk. So I is how much? What is I? It's a disk. So mr square by 2. So mass is 30 m r square by 2, right? So I by r square will be 15m. So this will come as 15m. Now you calculate. So this is m divided by 15. 15 plus 3, 18m, 18m into g. So from here g by 18 we are getting. So acceleration we are getting as g by 18. Once you got this acceleration, then substitute in that formula and find out the answer. Root under 2 into acceleration is g by 18 into height. Height is 3.6. 3.6. So if you remove this decimal, this g stands, this will get cancelled. 18 into 2, 36. So 2 will come out. So we got the answer as speed is coming as 2 meter per second. Correct? That should be the answer for this. Let us move to the next question. Question number 23. A capacitor with capacitance. So capacitance is given here, is fully charged with a potential difference is also given and disconnected from the battery. Okay, so that means it will get a charge which should remain constant. Now the charge capacitance is capacitor P is connected across another capacitor Q with capacitance this. The charge on capacitor Q when equilibrium is established will be this. Q does not have any charge inside. So that means one capacitor is fully charged. So that charge we can just write as C into V. So Q is equal to C into V. What is C? This. What is V? This. Just multiply that, right? C into V. You multiply. So how much it will become? It will become 6 into 10 to the power 60 into 10 to the power minus 6. Correct. Let us write in terms of minus 6. Okay. Right. Or you, if you want, you can write 6 into 10 to the power minus 5. Correct. This is coulomb, this is charge. Now what they are saying that this is connected with another capacitor. So let us say that this capacitor which is charge Q, it is connected with another capacitor. Okay. And what about the capacitances? They are different, right? This capacitance is double than that. So let us say this capacitance is C, this capacitance is 2C. 2C means it is 20 microfarad. That is 10 microfarad. Okay. So charge will be distributed. Now it will have charge Q1 and it will have charge Q2. Right? Because charge flow will happen. The charge on capacitor Q, right? Q means the second one here. When equilibrium is established, so what will be the charge here in equilibrium? So you know that voltage will be same. You can use that idea, right? So voltage will be same. So V is going to be constant now. V is equal to Q by C. So Q1 by C is equal to Q2 by 2C. So definitely here you will get that Q2 is going to be 2 times of Q1. Q2 is going to be 2 times because anyway its capacitance is double, right? And the sum of total charge Q1 plus Q2 is total charge which is Q. So we need to calculate what? We need to calculate Q2. So let us replace Q1 then. Then Q1 I can write as Q2 by 2. So write this Q1. So this is Q2 by 2. So this is 3Q2 by 2, right? So Q2 will become 2 by 3 of Q. Q is how much? 6 into 10 to the power minus 5, right? So from here 3 will get cancelled, 2 into 2, 4 will come. So 4 into 10 to the power minus 5 will come, right? 4 into 10 to the power minus 5. So this factor must be 4. So the answer alpha must be 4, right? Alpha must be 4. Fine. So let us move to the next. Question number 24. A cylindrical conductor of length 2 meter and area of cross section. Area of cross section, length is given. It is carrying a current. Current is also given. When its ends are connected to some battery is connected. Okay. Mobility of electron is given. Mobility is given. The value of alpha is. That means you have to calculate mobility. That's all. Okay. So how do we calculate mobility? What is the formula for mobility? And what are the things given? N, number density N is given, right? This is N. And what else? Charge of electron is given. That already we should know that. Okay, and what are the things given? Let us write. L is given 2 meter. Area is given 0.2 millimeter square, means 10 to the power minus 6, correct? Millimeter square. Then voltage is given 2 volt. Current is given 1.6 ampere, right? What is the formula for mobility? How do you define mobility? Mobility formula is drift velocity by electric field, right? Drift velocity, what? I is equal to NEAVD, right? So this is I divided by NEA, correct? By electric field. I is equal to NEAVD, so I by NEA. And what about electric field? Electric field. Electric field is V by L, right? Electric field is V by L. So what you get? This will come NEA. V means voltage here, okay? Electric field is V by L. That's all. So I is given, length is given, everything else is given. Now we have to do just calculation. Let us do that. 1.6 into 2 divided by number density 5 into 10 to the power 28. Electronic charge 1.6 into 10 power minus 19. Then area. Area is how much? 0.2. Or you can write as 2 into 10 power minus 7. Right? Then multiply with the voltage. Voltage is 2. So do this calculation. Right? So you can cancel out 1.6 very easily. This 2 will get cancelled easily. So in the denominator 5 into 2, 10. Everything will come in 10 to the power. So what it will be? Now write it. So this will give a 10, right? 28 plus 1, 29. 29 minus 19, it will become how much? 10. 10 minus 7, 3, 10 power minus 3. 10 to the power minus 3 we are getting in SI unit. SM. So alpha must be 1. Alpha must be 1. Correct. Everything we got it, right? Perfect calculation. No any difficult calculations. Okay. Let us move to the next. Question number 25 and the last question. An insulated cylinder of volume, this is filled with gas at 27 degrees Celsius and pressure is given. Then the gas is compressed, making the final volume as this while allowing the temperature to rise. The final pressure is. So what type of process you have to consider? You have to take this word insulated. Insulated means heat cannot change. That means delta Q0, that means it is a adiabatic process, right? Insulator mean delta Q is equal to 0. So it is a adiabatic process. Adiabatic process. So once you got that it is a adiabatic process, then you think, and temperature and volume relationship we can consider while allowing the temperature changes are there and compressed, right? So volume is decreasing. So volume is decreasing from 60 centimeter cube to 20 centimeter cube. Volume is changing, right? And what about the temperature rise is happening. So initial 27 means 300, remember 300 Kelvin you have to take, and this is 77. So 77 plus 273 you add. So how much it will become? 273 you add. How much it will become? 15. 350. 350. 350 Kelvin is the final temperature, right? Okay, so temperature volume relationship adiabatic process, they are asking final pressure. Remember, they are asking final pressure. What is initial pressure? Initial pressure is 2. So 2 atmosphere, and final pressure is what they are asking. So we need to think about what equation we should use. They are asking pressure. So we should use pressure volume relation or pressure temperature, whichever is easier, but pressure volume will be easier. What type of gas it is? What type of gas it is? The gas is because gamma will be a factor used, correct? Insulator cylinder of volume 60. So from here, these two equations we should use to calculate gamma then, and then gamma we can use. So what is temperature volume relationship? Tv per power gamma minus 1 is constant, correct? So we can use that. So we can say that temperature is proportional to 1 by volume power gamma minus 1. So if I use this condition, so final temperature 350, initial temperature 300, this ratio must give uh, volume. Final volume is 20, initial volume is 60, this power gamma minus 1, correct? So of course it is going to give us 3. So 3 per power gamma minus 1 is coming as how much? You can calculate that 5, 7, 5, 6. So 7 by 6 it is, correct? This may be little bit simplified because 3 per power gamma, right? 3 per power gamma divided by 3, so that will become 7 by 2 here, correct? So this idea we got it. Gamma we do not know what type of gas, so then we can use PV per power gamma as constant. This we can use. So pressure is proportional to 1 by V per power gamma. So P2 by P1 will become what? V1 by V2 power gamma, correct? So we can use that. Now final pressure and V1 by V2. So we already know that V1 by V2 will give 3 factor, right? So this become 3 per power gamma, and this is final pressure by initial, so multiply initial pressure. So 3 per power gamma we have calculated 7 by 2. So this answer P2 should be 7 by 2 multiplied with the original pressure, which was how much? 2. So this is going to give us answer as 7. So final pressure will be 7 atmospheric pressure, right? That should be the answer. So answer will be 7. Final pressure is 7 atm. Fine. So I hope you have got the idea of different types of questions coming in, various shifts. So we'll continue solving the other shifts problems also. Thank you for your attention.